Hello everyone! Today we are going to speak about active sensors and missile fire control. They are grouped in one research project because they are very much alike. So what are active sensors and what is missile fire control? Well, we're going to start with active sensor. Basically, it's best described as what bats do. Your ship or your sensor starts sending out, when activated, huge pulses into the surrounding space. When there is an object present in the range of the sensor, it is hit with this pulse of energy. The signal then rebounds back to your ship, and the sensor tells you that there is an object, estimated size, this and that, in this spot. So you run off having a target or a ship in its range. Now, there are a couple of things that you need to learn and understand before you start using active sensors. First, any ship that is hit by your active sensor blast or pulse, immediately, almost immediately, if it's equipped with a passive EM sensor, learns that it is being probed and scanned by an active sensor. Also, this is by many races in the game considered a pretty hostile act because, it means that you are actively searching for their ships in the vicinity. Third thing that you need to know is that it does not always work. Why? Well, the sensor has a couple of things that you can see down here, like resolution, maximum range versus a certain object or larger, and then it has shorter range versus smaller object. So basically, if you set a sensor for, say, a size of 5,000 ton object in this setting, you will detect it up to 6 million kilometers. However, if that object is way smaller, say 250 ton object, the same sensor would only be able to detect it as range of 15,000 kilometers, which is basically right next to you in Aurora type of scale. So what does this mean? It's very much suggested that you design and equip your ships with more than one type of sensor. I'm going to show you how this works right now. There are a couple of technologies that come into play when designing sensors. First of all, there's active sensor strength. I have given myself a couple of these for the sake of showing you the difference. Then there is EM sensor sensitivity, which is actually the passive sensor technology. So this one is functioning for both EM sensor sensitivity in active sensor technology and for EM sensor itself, or EM passive sensor, so you understand what I'm speaking about. Now there's also a total sensor size in house space, so that means tons. Remember, one size of 1 is 50 tons. Then there is a minimum resolution, which is what you're tuning your sensor for, again in house size and tons also written here. Then there's a hardening, which doesn't come into play until much later. And then there's active sensor type, which is third sensor. You can only switch this to missile fire control. Now let's have a hypothetical situation here. We are designing a heavy cruiser. The ship itself is going to have about 12,000 tons. That sounds about right for a mid-game heavy cruiser, at least for my games. So the sensor we would be designing here could have potentially, say, a size of 10, which means it would have 10 house size, about 500 tons. Now, however, I want two kinds of sensors on my heavy cruiser. We will have a sensor designed to detect ships and a sensor to detect incoming missiles. Later on in game, you can have also a middle ground, for example, to track things like corvette-sized ships, which are around 1,000 tons, sometimes referred to also as fast attacking craft. So let's start with the long-range sensor, which is going to be set for, well, it's a heavy cruiser. Let's say we're gonna set it for 8,000 tons. Now, at active graph sensor strength 10, which is what you are starting with, and EM sensor 5, you will have a range of around 63.2 million kilometers versus an 8,000 ton object, which is decent. 63 million kilometers, that doesn't sound bad. But you can check that if that object would be 250 tons, it would only be detected at 61,000 kilometers, which is basically, again, right next to the ship. Now remember, missiles do not have 250 tons, they are way smaller. So this sensor, let's call it long-range sensor, would have the ability to detect this missile basically at the point where it's hitting its hull, in the game sense, because you have a 5-second increments as the shortest time. So at the moment you detect it, it will be, say, at around, could be 20,000 kilometers away, and missiles usually go at around speed of at least 10,000 kilometers per second. So no matter what you do, those are hitting you. So for this thing, we are going to design another sensor in a second that will deal with the smaller objects. However, let me first show you how this range increases when you have better technology. So at 10 it's 63.2 million, at 12 it's 75.8 million, at 16 it's 101.1 million, and at 21 it would be around 132 million, which is pretty good. When you increase the EM sensitivity, you will notice that it bumps up significantly as well. So both of these technologies are very good to have for this. I think though that the active graph sensor strength also greatly increases the research cost of the project. So be wary of that, basically it scales. At 10 it's 1,000 and 21 is 2,100, so that is understandable. Okay, so now we have a long-range sensor that's capable of detecting, let's tone down, at some 63 million kilometers. That is decent, 63 million kilometers. I call that a decent range on a Starlink sensor. However, what about those missiles that are coming at us and that will hit us before we even see them properly? Well, you can create another sensor that will be toned to 50 tons size. Now the range is going to drop significantly because it is way smaller object and it's much harder to detect. However, this one hull size or 50 ton active search sensor, by the way, this is the smallest size that you can set your sensor to, the minimum resolution, 50 tons, will detect a size 6 missile or smaller at almost 500,000 kilometers. So that is way better than the previous sensor. If the size is bigger, for example, if it's an size 8 missile, it will have 800,000 kilometer of range on it. And if it's a size 12 missile, you will detect it at almost 2 million kilometers. A 50-ton object, I cannot imagine what that would be. 50-ton object, that would be either a very huge missile or something. I don't think there's something like that. You cannot design a ship like that. This is the minimum size, for example, for an engine. That object would be detected at 5 million kilometers. You can see that it doesn't scale linearly. It goes exponentially. You have the maximum resolution and then it scales down, not linearly. It's actually not completely exponential, but these numbers should give you a rough estimate how the sensor is going to perform. I do not know the exact math beyond these calculations. They're actually very complicated, and I don't even think I want to calculate it. I'm just doing it well with the numbers the game provide me with. Now, if we go to active sensor strength 21, you can see that it scales up again to 10.5 million kilometers. So that is pretty good. With EM sensor sensitivity 6, you would get to around 12.6 million kilometers. That is a lot of time for you to decide what to do. If it's a size 6 missile, which would be very, very small anti-ship missile, you would have at least 1.3 million kilometers added. If a small missile of a smaller size 1, 2, 3, 4, and 5, has also the same detection range. So this is decent. That would give you a fair warning for you to either launch your anti-missile missiles or turn on your turrets and start, sending laser blast or meson blasts or whatever type of laser things you have mounted on your ship, or gun type things. Okay, so this is cool. However, you can still see that this doesn't have an optimal range against, say, we can call it fast attack craft, which is basically bombers and fighters. For that, if you have time and size of a ship, you should also create a sensor aimed at 500-ton objects. Now, 500-ton object is the maximum size of fast attack craft, like a fighter and a bomber. So 500 tons is a decent object size for you to go for. You can see that it detects it at almost 19 million 15.8 million kilometers. That's also very decent. However, this brings me to another very important point that I struggled with for a bit to wrap my head around. If you design an active sensor, say of a minimum resolution 500 tons, you will detect any object of 500 tons or larger at this range. If there is a 100,000 ton ship at 16 million kilometers, you will not detect it at all, which is the reason why I'm saying that you should use a couple of different sensors. I really think that the long-range sensors should be set to slightly below the size of your ship. That, from my experience, works best. If you would have, for example, a 20,000 ton ship, the long-range sensors I would set for about 15,000 tons, for 3/4 of its size. So that would give me an 86.6 million kilometers on anything slightly smaller than my ship. However, you can again see that the scaling is pretty intense. A 1,000-ton object would be detected at 384,000 kilometers, and 250-ton object at 24,000. So a missile would basically again hit you before you even know it's there. So this is my advice for any ship that will actively work with combat situations. You should have at least 2 sensors. You can have a long range, which would be targeted at about 3/4 of the size of your ship at maximum range, and you would have a short range sensor that would be detecting missiles, minimum resolution, so that would be 50 tons, and that one would be used for, say, anti-missile defense. There's no other better way how to say it. If you have a really good ship that can have a third type of sensor, I would really probably recommend 500 tons as the middle ground, because that seems like a good anti-fighter sensor. Now, there's also a couple of other things to say about this. For example, if you design a corvette, a ship around the size of 1,500 tons, 2,000 tons, or maybe even a frigate around 3,000 tons, you would my recommendation would be rather have one larger sensor with a 50-ton resolution set that would be of size 10, for example, than two smaller, less useful sensors. On small ships, it's just better to have only short-range sensors, because you are effectively, any weapons you will carry on that ship will be way less, the range wouldn't be so big. I'm trying to explain this in as many words as I can to allow you to wrap your head around it, because it's a bit iffy, but for small ships that can only have one sensor, I would really recommend having a 50-ton resolution sensor on them. It's better, definitely better, because you can see both missiles and anything that is bigger on that range as well. So 5 million kilometers, it's not much, but it still gives you a fair warning, because 500,000 kilometers to size 6 or smaller missiles is decent. Another thing that I would like to mention is that there's a couple of good uses for sensors. For example, when you're designing a PDC, I will speak about this later, you can have large, very large listening posts installed on asteroids or small moons that will have a massive sensor on them. So just that you understand what I'm speaking about, if you set your sensor size to 50, which would be around, if I calculate this correctly, it should be around 2,500 tons. Yeah, 2,500 tons. And you set it to maximum resolution, you would, at the very basic level of technology, get 500 million sensor strength at 25,000 tons. Again, it scales really bad against missiles, but nothing really stops you from adding another massive sensor aimed at missiles, which is really good when you have, say, Earth defenses, because you can detect any missile at around 3 million kilometers, which gives you insane amount of time to prepare yourself for any impact. If it's a big missile, I have no idea why anyone would send a size 6 missile against a planet. You have way more warning time as well. Again, this scales insanely when you get to higher technology levels. So yeah, that's a good thing to have. Also, you can create listening posts at jump points. If there is a system you currently don't have the capacity to scan for aliens, you can either go with passive sensors, but you can also go with a decent platform which would have 5,000 tons or 10,000 tons size, and you would just basically mount as many sensors of different resolutions on it and have a early warning system in place. So that seems like a good way how to design sensors. If you have any questions to this, shoot. The sizes of your sensors really depend on what you are designing, what kind of missiles you are designing, what kind of missiles and the range you are carrying, many things. It has to be in balance. There is no need to have, for example, a large range sensors one. Basically, it's always good to know where your enemy is, but just don't go overboard with it, because sending out massive pulses through entire systems while you are basically unable to utilize or act on the information you're getting, it's not really all that useful. Now this brings me to another thing, which is the missile fire control. You can see that all the information basically remains the same, except missile fire control is needed to guide your missiles. The range is actually way bigger on the missile fire control because information from a search sensor are directly fed to your missile fire control. So this is basically like a one-way information feed to your missiles. You launch a missile and then navigate its path by sending direct information from your ship to that missile. Turn, I don't know, 30 degrees to the left or right, depends on the coordinates that the race will be using. So on all ships that are using missiles, you need a search sensor that would pinpoint. For example, let's have a good example here. You're going to have a huge battle cruiser of 25,000 tons. You will know that the enemy ships are around 12,000 tons. So you're going to create a 12,000 tons minimum resolution sensor. This sensor has almost 1 billion kilometers at this technology level on a 12,000 ton object. It also has around 7 million kilometers on an object that has 1,000 tons. This is okay because most of the ships that you saw from the enemy are about 10 to 12,000 tons. So you estimate the range would be around 600 million to 1 billion kilometers. Cool? You're following so far. If you turn on your active sensors, you will get most ship contacts on around 0.6 to 1 billion kilometers. So you need to design a missile, and we will do that in one of the later tutorials, that has a range that is similar to this range, basically. Because when you learn of a ship that's 800 million kilometers away, you want to hit it. So you will design a missile that will have, effectively, you would need something a bit more than this as far as the range goes. I'll explain why later on. But for now, let's say that you expect most contacts to be at around 1 billion kilometers, and you will detect these ships at around 1 billion kilometers or less. So when you launch your missiles, you also need a missile fire control that will have around or above 1 million kilometers worth of range. So you need something that is actually quite smaller than this. You can have a missile fire control that would be around, I'd go about size 20. Actually there really is no need for that, but size 18, that sounds about right. The size 17 would be less than 1 billion. The reason why I would design the missile fire control to have a bit more of a range is that you might have a couple of ships overlapping each other, and one of the ships can be slightly behind. It can, that this would be 100 million kilometers. That actually is nothing. Unless you always keep your ships together. Imagine one of them being slightly behind. So if that one would launch its missiles and have top range of its active sensor range, then it cannot act. You sometimes can get information from different sources than your own ship. And this is actually really important because you can have a couple of ships out of which only one. For example, if you have 5 corvettes, again, we are going to speak about this when we design ships, but it's good to give you this advice in the beginning. You can have, for example, 4 ships. 3 of them will carry missiles, and 1 of them will not carry missiles. Instead, it will be basically a sensor ship. It will have numerous sensors on it that will be like feed of information to the other ships. So every single of those 3 ships that will carry missiles actually only need missile fire control, while the 1 ship that will not have missiles can have the active sensor. And the fact that you have an active sensor contact from any of those 4 ships means that all of them, even though they might not themselves have an active search sensor, can fire at that target. So that's good to know. For example, if you have a ship that gets its sensor knocked off by a hit or some kind of malfunction, you can still launch its missiles if any other ship is able to have a positive active sensor lock. I guess that makes sense because your ships communicate between themselves, of course, you know. So bear that in mind. However, in most cases, I would really recommend every ship has at least some sensor, because even though you might have a ship that has very good sensors, you might come into a situation, for example, where the AI will target and destroy your sensor ship. In that case, all the other ships would immediately go blind, especially if you don't even mount a short-range sensor, anti-missile sensor on any of those ships. Any of those ships would be basically completely blind against incoming salvos, and any anti-missile defenses you might have put on them would be completely useless. So bear that in mind. It's good to specialize, but some kind of active sensor on each ship will do you good in the long run. So last thing that I haven't spoken about is the hardening. The hardening is something I don't have much experience with. I will say that outright. I don't really use it all that much, but when I get the research points, I research at least a bit of it. Electronic hardening gives you chance to resist electronic damage from electronic warfare weapons. At hardening level 0, you have a 100% chance of your sensors being destroyed by electronic warfare. At level 1, the chance drops to 70, so you have a 30% resistance. At level 2, it drops to 50, and at the level 3, it goes down to 40. I don't think AI uses electronic warfare much, but I'm pretty sure precursors and some types of aliens can use it. So if you have the spare points, do it and be safe. That's the best advice I can give you about electronic hardening. So yeah, if there are any questions, let me know. This is basically the tutorial on search sensors and missile fire controls. Again, this is just the general layout. What has to happen is that once you start getting context for the enemies in the game, you will have to specifically tune your sensors and their resolutions to the specific enemy you're facing. But it's good to have some sort of basic layout to start with. In my case, it's for small ships, short-range sensors. For bigger ships, short and long-range sensors, tuned to about 3/4 of the ship size. And then when you get really big, you can add mid-range sensors against attacking fighters and bombers. So I hope this helped you. I'll be glad to answer any questions. And if there are no questions, we can move to the next tutorial video.